Okay, so this is question 4 from exercise 11a from the first year mechanics textbook. So we've got displacement as a function of time, and it's about a toy car that starts off at point P and then moves in a straight line from P before returning to its starting point, and we've got S in terms of T. Okay, so the first thing they want is the maximum displacement. So looking at this, I can see it's a quadratic and it's a negative T squared. So if I need the maximum, so it's that shape graph, so basically I'm after to that value there, I need the vertex. So I can either do that through differentiating, or I can do it through completing the square. So the actual function was that S equals 1/5 of 4t minus t squared. So let's complete the square, or to be honest, you could just put this straight into your calculator. So I'm going to take minus out as a common factor and change those brackets to t squared minus 4t. So that's going to become minus a fifth t minus 2 all squared minus 4. So the vertex of that is going to be at 2, and then in fact let's multiply those outer brackets out, so it's minus a fifth t minus 2 all squared plus 4/5. So the vertex is at 2 4/5. So I'm after, so that's going to be the value of t at the vertex, and that's going to be the value of S. So the maximum value of S is, sorry, what am I talking about? It's not, so 5/4, right, is 4/5, so 0.8 meters. Okay, part B, the time taken for the toy car to return to P. Okay, so that's going to be when the displacement is 0 again. So in fact, if we just sketch this quadratic out accurately, so I just do the general shape of it for A, but let's actually sketch it properly. So S is 1/5, and then let's take t out as a common factor as well. So 1/5 of 4 minus t. So that tells me I've got roots at t is 0 and t is 4. So in fact, I mean, that is the answer to part B. So it started at P, so it was at P when t is 0, and then it got back to P when t is 4. So let's just have a think. So that's what this quadratic looks like. So we've got an intercept at 0, we've got an intercept at 4. We worked out the vertex for part A. Okay, so that's a more accurate sketch of the graph, might help to just clarify what we were doing in part A. Okay, so part C, the total distance travelled. So we need to figure out, so basically it went from, let's go back to our sketch. Okay, so it started at P, it travelled away from P until it reached its maximum distance, and then it travelled back again. So after 4 seconds, its displacement is 0, but its actual distance it's travelled is 0.8 meters to get to that point. So it travelled 0.8 meters away from P. So then it must have travelled 0.8 meters back again. So it travelled 1.6 meters altogether. And the values of t for which the model is valid. Okay, well, it returns to the screen. It returns to P after 4 seconds, and that's when its journey ends. So it's between 0 and 4 seconds.